All right, so we're talking about extreme values. These are both extreme. Extremely high, extremely low. And those are called local maximum and local minimum. Guys, stuck enough. Okay, focus on, excuse me, are you on the right page? This is the right page. That is the page where you need to be right now. Please skip there. All right, increasing or decreasing? It's increasing in this little zone right here. And how do you describe that? You say it's from negative infinity until it hits what? Does it stop increasing? Then you say it increases until it hits the x number. That's this one. So it increases until negative 2.4. Would you please, on your iPad, answer this one for me? Where is it decreasing? From where to where? Remember, only one of the two numbers is the ones we use. You can look at my example if you want to see which one's which. Don't tell everybody which numbers to use. I understand. By asking your deli. There's only one of the numbers you use. You don't use both letters, you use one of them. Yes? Oh. All right, yes. My phone was plugged in because I was going to play some music after we're done with this, but it had a text come in, and so it made a loud noise. All right, so I have the charger up here, and yes, you may use it. Okay, we got to keep moving here. Yes, you're supposed to be telling me increasing or decreasing. No, not brackets, you use parentheses. And the reason is because brackets would imply it is increasing at that spot. At that spot, it has stopped increasing right there. So, you know what I mean? So you don't use brackets, you use parentheses. Now, decreasing, it's the x numbers again. So I go negative 2.4 up until it hits 1. Raise your hand if you had that one right. Okay, good. Moving on. What type of root is this? That's a single, that's a double, and what do you think that is? A triple. All right, so there's single roots, double roots, and triple roots. What's the equation for each of these graphs? All right, well, I know there's a triple root at this, which is 3. So I can write my equation with a triple root at 3. X minus 3, and it's a triple. How do I do that part? X plus 2, and what kind of a root is it? Double, so I'd write that. You get how I just did that? This one was a triple root right here, and this one was a double root, because I can tell by the shape of it. But would you please write me the equation for that one? Starts with y equals, and it has 2 sets of parentheses. Yes? You would add these together and say 3 plus 2 makes 5. If it was written in general form, you would just find the biggest one. In this case, there would be degree 2. Don't add them together when it's in general form. You do add them together when it's in factored form. Yes, if you multiply it out through factored form all the way out, then you can just pick the biggest one. It would be the same answer as if you added this. Because if I actually multiplied this out, I'd have an x cubed in it, and I'd have an x squared in it, and when I multiplied them, I'd have an x to the 5th in it. So if it's in general form, the biggest one would be x to the 5th. So if you want to think of it that way, this just needs to be multiplied out first, and then you could know what its degree was, which would be x to the 5th. Therefore 5. All right, this one you should have said y equals the 2 sets of parentheses, and then it's 1 is going to be x minus 1, and that one's a bounce, so it's squared. And this other one is x plus 4, because it's a minus 4 right there. And then that one's a cut through, so it's degree 1. You don't have to put the 1 there, it's optional. Raise your hand if you had that one right. Okay, good. Let's move on. What is the degree for this one? It's easy. What is it? Degree 7. This one's not easy, but it's doable. It's degree 5. Because you have a 1 here and a 1 here, and you add them all together. Degree 5. Because if I did multiply this all the way out, the final answer, it would have an x to the 5th. I don't know why I said 5, because you said 5. Okay, sorry, it's 6. 4 and 1, and 1 doesn't add up to 5, it adds up to 6. Okay, sorry about that. Moving on. This one, x to the 3rd is, no, there's the biggest one. Do you see how that one's 8? even though it seems like it should be this first one, it's not always the first one. It's the biggest one. That's the biggest one. So 2, 3, 8. Okay. Now, the other thing that's important is, remember how the lead coefficient tells you by whether or not it's negative. This tells you whether or not this thing is going to go up or down at the end of it. Since the lead coefficient is really this third one right here, I can see it being negative. This graph has to go down at the end because it's negative in front. Remember that? Do you also remember that when they're even like this, that they both have to go the same direction on each end? So it has to be down and down. Okay, we'll talk more about that in a minute. What is the end behavior for each function? So this one. What's the lead coefficient? That one. Once I've got the lead, then I know, since it's odd, they must be going opposite directions. Like, one end must be up and the other end must be down. And this lead being negative tells me that the right end must be up. So this one would be on the right, it would be down. On the left, it has to be the opposite of that because it's up. It must be up. Always start with the right side. Because all that is the lead term negative. The lead term here is this one. That. It's not the very front one, it's this one, because it's the biggest one. So if it's negative, it's down on the right. Done. Now I can look at the left and say, is it the same or is it the opposite? The same, because this is an even one, and therefore it must be the same as the other. All right, and the last one, what's the lead coefficient here? It really doesn't have one, so you got to make the lead coefficient would be this times that x, which is to the 1 power if you want to do it, and then this x. And you say x to the 5th, x to the 2nd, and x to the 1st makes x to the 8th. And there's no negatives anywhere on that. So therefore, the lead coefficient is positive 1. X to the 8th. So then I'd start and say left or right. Which side do I tell you to start up? The right. And this being positive, it's going up. Right? And then since it's even, all right, I did all of those. I want you to try one. Everybody write down what you think this is. Right, left, right, right. Here's the question. What would this one do as its left and its right? Negative 6x squared plus 2x cubed plus 7. What would it do on the left? Well, I can tell you this much. If you get sucked into using this term, you'll be wrong. Because that's not the lead. Why isn't it the lead? Because the lead is actually the one that is bigger. That one's the lead. So I look at that, and it'll tell me the right side should be up. And I look at that, and since it's odd, it must be different. So it's down. So left is down, right is up. Raise your hand if you had that right. Good. Moving on. And we're done. Yay. So, you have time now to work on your homework. And your homework is mostly, yes. Your homework is mostly doing problems that are just like we just talked about, polynomials. There's one little section on the homework that I think is a little bit tricky, so I want to talk that through with you. Look at problem 40 on your homework. 40. Problem 40. Oh, there they are. Okay, problem 40. All right. Do you remember how to find the roots? You can factor it if you can, but what if it's too nasty to factor? Yes, the synthetic. And yes, there's a divide and conquer on the 4-part kind. We're not going to do much of the factoring today, but let's just say it was a really nasty one. In fact, I think I have it right. Let's say it was a really nasty one. Remember what you did? Remember what? Yes, you can do that, and it's the factors of this divided by the factors of this, but we have a new way now that's better. That is a way to do it, called the rational root theorem, but you're not being tested on that. Because you now have a better way. We use technology now. Yes? Yes? How do you do it? Yes, you graph it and you find out where it touches. So, would you please look at this one and tell me, if you graph that, don't interrupt please. If you graph that, where would it touch? All right, this one's a multiple choice, so it's much easier, but it still kind of freaks kids out. Would you please do 41? Graph it right now on your calculator. Calculators will be allowed, yes. That's kind of the point here. Once you've got this thing graphed, you've got to use the whole fact that it's multiple choice. In other words, you'll be able to say, well, it can't be this one, because it's not anywhere near -2. And it's not anywhere near 4. And it must be touching one of these other two spots, so look close and see which one it actually touches by. Is 4/7 pretty close to half? Isn't that pretty close to 1/2? Okay, 4/8 is a half, so it's pretty much a half. Is the graph going anywhere near positive a half? No. How about that other one? This one's just a little more than -1. Is it touching near -1? If you zoomed in on that with the zoom box, you'd find it was touching at 1 point something. So that's the one that's closest. So the others aren't even possible. Hopefully you saw your graph and it looks kind of like touching. And it, actually, if you zoom in on that closer, you'll find that it was touching past 1 at -1 point something, which is, this means this is the only one that was possible. Okay, so bottom line is you graph these puppies and you see where they touch. You do not have to do synthetic division to find all of the zeros. You can just graph these things and see where they touch. Now, I do want you to understand how that works so that if you have one like this, do you remember how to do 4-part factoring on this? Okay. And then, yes, you could divide and conquer. And go 3x squared comes out, x plus 2 left. 5 comes out, x plus 2 left. And then remember how this and this are the same, so they come to the front, x plus 2, and then 3x squared plus 5. Remember all that? Okay. That's 4-part factoring or divide and conquer factoring. But doesn't it tell me that -2 is a root of this? Alright, so now, if I'm telling you -2 goes into this, would you please use synthetic right now on your iPad? Use synthetic to show me that -2 actually works. You forgot, that's how you start it. You look and see if there's any missing terms. 3, 2, 1, and there's a 0 term at the end. There's no missing terms. If there had been, I'd have to have a 0 in the list I'd thrown in like that. But I don't have any missing terms. Okay, so then the 3 drops down. 3 times -2 makes -6. Add them, 0. Multiply them, 0. Add them, 5. Multiply them, -10. Yay, it worked. So, remember that? So now, what it means is, this right here comes down and becomes x plus 2. And this right here becomes 3, and this would be the x, and this would be the x squared. It would be 3x squared plus 5. Get that? Same thing we got before, right? All right, so it's just two different ways to do it, and I just showed you synthetic, and I also showed you the divide and conquer way. But the 4-part one, divide and conquer, is pretty awesome. But you're right, it doesn't always work. You have to know synthetics because the calculator will always tell you this number right here. Once you know that number right there, then you know you can use synthetic to get the answer. All right, I'm going to ask you to do one more synthetic to just make sure you understand what's going on here. Do synthetic on that one. Okay, this drops down 7, 14, add them, 20, multiply that, 44 minus 10, 34 times 2, 68, didn't even get close. You know what this is called at the end? It's the remainder. One of your questions is going to ask you for, what's the remainder if you do this? The last number, if it's not a 0, that's the remainder. Okay, covered everything you need to know. Time it is to work on that the rest of the time.